The next question that I am going to solve here is from exercise 1.2, question number 5. Check whether 6 raised to power n can end with digit 0 for any natural number n. So, how we have to solve this question? First of all, which number end with digit 0? Think about that. The numbers like 10, 20, 30, 40, 220, 250, 240, all these numbers are ended with digit 0 at unit place, right? Now whichever number that end with digit 0, if you see one thing in their factorization, that is like 250 is 25 into 10, right? So let me see few examples. Here we do say number 10 is there, or 250 is there, or 240 is there, right? Now what is 10? 10 is 5 into 2. 250 is 25 into 10, that means 25 into 5 into 2. 240 is 24 into 10, 24 into 5 into 2. 130, 13 into 10 means 13 into 5 into 2. So what you have seen in all these examples, if you will see the digits that end with digit 0, the numbers that end with digit 0, in their factorization 1 5 and 1 2 is must to make the 0 at unit place, no? So what is there? So we get one rule, okay, any number that end with digit 0 must have at least 1 5 and 1 2 in its prime factorization, because 1 5 and 1 2 if we multiply that becomes 10, and any number that we multiply by 10 will definitely end with digit 0, right? So first thing, we have to check whether 6 raised to power n can end with digit 0 for any natural number n. So we should know the rule. We should know on what basis we have to test 6 raised to power n. So we have to write the rule. Let me write solution. We will write condition. Any number that ends with digit 0 must have 1 5 and 1 2 in its prime factorization, right? So what we have written, any number that ends with digit 0 must have 1 5 and 1 2 in its prime factorization. Must have at least word is also important. So any number that ends with digit 0 must have at least 1 2 and 1 5 in its prime factorization, right? Now we will test the given number on this condition. So 6 raised to power n. What is 6 raised to power n? It is 2 raised to power n into 3 raised to power n, right? So, right, and in question it is very well given that n is a natural number. So n can be 1 2 3 anything, but not less than 1, right? So here it means 2 is definitely there in this, but to make the number end with digit 0 we should have 1 5 and 1 2. So 2 is there, but there is no 5 in the prime factorization, you can see clearly. So we will write as there is no 5 in the prime factorization of 6 raised to power n. So 6 raised to power n can never ends with digit 0 where n is a natural number, right? So there is no 5 in the prime factorization of 6 raised to the power n. So 6 raised to the power n can never end with digit 0 where n is a natural number. We are following the fundamental theorem of arithmetic here, and that states the prime factorization is unique. So here 6 raised to the power n will always be 2 raised to the power n into 3 raised to the power n, right? So this is the solution of the question. The next question is question number 6 from 1.2 exercise. Why 7 into 11 into 13 plus 13 is a composite number, right? We have to show why it is a composite number. Actually what they are asking in the question is, if you notice, they have given the number 7, 11, 13, all are what? 7, 11, 13 are prime numbers, right? And we know that product of two or more prime numbers will always be a composite number, product of two or more numbers. But they here what they have done, they have added one prime number in that, no? And they want to know, okay, if this thing we do, then will it be a composite number? Right? To see how we will solve it, the first thing, let me write the question statement again. 7 into 11 into 13 plus 13 expression is this. Now don't you see there two terms, because plus sign is there in between, and plus or minus sign makes the terms of the expression. So from these two terms we can take 13 common. 13 gone out, 7 into 11, 77. 13 gone out, so in place of it 1 will be there. So 13 into 78. We can factorize 78 further, but there is no need. Why? Because we know that composite numbers are what? Which numbers? The numbers which have two or more factors other than 1 are composite numbers, right? And here 13 and 78 are two factors other than 1. So it is a composite number. We will write, we know that a number having two or more factors other than 1 is a composite number. So 7 into 11 into 13 plus 13 is a composite number. Answer, right? So this number is a composite number. I hope you understand.